Hi, I'm Sakshi Kadkur, third year undergraduate student from the Department of Chemical Engineering.
Hi, I'm Abhinav Anand, a BTech third year student, currently pursuing chemical engineering.
Hi, I am Amit Hasne from third year chemical engineering.
I am Mansi Kulkarni from BTech third year chemical engineering. This is group E1 and we have been allotted the project of pool boiling for a heat and mass transfer course. This video summarizes our understanding of pool boiling so far, our progress towards assembling the experimental setup and planning the experimental procedure. Over to Abhinav for an introduction of pool boiling.
Yeah. So, pole boiling experiment are one of the significant studies in the field of thermodynamics and heat transfer. This experiment would help us understand how heat is transferred between a hot surface and a liquid when the liquid undergoes a phase change from liquid to vapor. This experiment focuses on process of boiling that occur when a liquid is placed in an open container. The main objective of this test are to look into and evaluate the boiling process's heat transmission characteristics, the efficiency with which heat gets transferred from the heated surface to the liquid when it boils is a topic of research. In order to simplify the experiment and analysis, we have chosen water as our fluid. The goal of this project is to obtain understanding of the mechanics underlying heat transfer during boiling. So the objective of this project is to obtain the pool boiling curve for a 10 cm long and a 1 cm diameter of copper rod, and to evaluate the critical heat flux and observe corresponding bubble formation.
So critical heat flux is one of the major design and safety parameters, and critical heat flux has immense applications in cooling networks. So it is very important for an experimentalist to know the value of a critical heat flux of the surface temperature beforehand. So when an experiment exceeds the value of critical heat flux, we observe a rapid increase in the temperature. And on a large scale, it is very difficult to control this temperature increase, which is the major cause for accidents. And so when the critical heat flux exceeds, it results in a transition from nucleate boiling, which has a high heat transfer efficiency, to film boiling, which is a very low heat transfer efficiency. And the point at which critical heat flux is exceeded is known as the boiling crisis. So, in order to avoid this uncontrolled increasing temperature, it is very important for us to know the value of critical heat flux for a given test temperature. And henceforth, the experiments are operated in the range of nucleate boiling, and the heat flux provided to the test surface is well below the critical heat flux point.
Hi sir, this is Mayur Patil and now I'll be explaining about our setup. So the transparent water bath shown here serves as the container for the experiment. It allows us to observe the boiling process and the bubble dynamics. This feature is essential for visualizing and recording the phenomena during the pool boiling. The cylindrical rod shown here acts as the test surface where pool boiling occurs. The choice of copper, aluminium or the stainless steel allows us to investigate how different material influence the boiling process and heat transfer characteristics. The cartridge heater is inserted into the cylindrical rod to provide the controlled heating to the rod surface. This heating element allows us to maintain a specific test surface temperature independent of the water temperature. The variac shown is used to control the power supplied to the cartridge heater. An immersion heater is used to heat the water pool in the transparent bath. It is immersed in the water and connected to the temperature controller. The temperature controller helps to maintain the desired water temperature during the experiment and ensures that the water is at the set boiling point. It also regulates the power supplied to the immersion heater. By monitoring the water temperature using thermocouple, the controller can adjust the heating element's output to achieve and maintain the desired temperature for the boiling experiment. The thermocouple is placed in water to measure and monitor its temperature. The thermocouple is connected to the temperature reader that provides real-time feedback on the water's temperature. This information is crucial for controlling the water bath's temperature. Another thermocouple is placed at the surface of this cylindrical heater rod. This thermocouple measures and records the temperature of the rod surface during various boiling regimes. A microscope camera and LED light source are used to visualize and record the bubble dynamics during the pool boiling process. The camera allows detailed observation of bubble formation, growth, and departure from the test surface. This visual data is valuable for understanding the boiling process. So now I'll be explaining about the procedure that we'll be following to perform the experiment. First, we'll place the immersion heater inside the water and cartridge heater at the center of the copper rod. Then we connect the cartridge heater with the variac and turn on the immersion heater, variac and thermocouple sensor. Then we will be allowing the thermocouple readings to reach a steady state. Once a steady state is reached, we will observe the bubble formation. The point of highest bubble density indicates the critical heat flux of the copper. The pool boiling curve for critical heat flux through the copper rod versus the temperature difference between the surface of the copper rod and water temperature is to be plotted for at least 3 different water temperature. After getting the glycol spray, we will enhance the wettability of a copper surface. The experiment is to be repeated again and the pool boiling curve is to be compared to the previous one. Now, when the bubble formation starts, the pictures are taken using a camera to determine the bubble size. The captured images are pre-processed in the Python's OpenCV library like cropping images, edge detection, and thresholding. Using contour detection, we can identify the contours of bubbles that will ultimately help us to identify the bubbles. Small contours, that is small sized bubbles, can be neglected as a noise. By measuring the size of the bounding box around each bubble, we can measure the diameter of a bubble. And then the same process is repeated for all the captured images. So here is the short demo of the experiment that we performed to show how the bubble formation takes place at the surface of the copper rod.
So here are some of the industrial applications on pool boiling experiment. So as pool boiling experiment are used in various industries to study boiling liquid on the heated surface, here are some of the practical applications. So the first is in the aerospace industry. So this experiment plays an important role in ensuring the reliability, safety, and efficiency of various components and systems used in aircraft and spacecraft, contributing to the advancement of space exploration. So the second application is in the healthcare sector. This experiment optimized cooling for MRI machines, laser systems, and other devices, ensuring accurate and safe medical treatments. It also helps to design storage systems to maintain vaccine effectiveness. In the food industry, continuous development of new products and new technologies are ongoing. Here, pool boiling experiment contribute to the development of innovative process by providing insights into the heat transfer properties of food products. So here are the challenges which we faced during the setup process. We used acrylic material to make the box, whose melting point is around 160 degrees Celsius, but the deformation in the box started at around 90 degrees Celsius. When the water is added into the setup containing immersion heater and the copper rod, we observed bubble formation. So the challenge here is to differentiate between these bubbles and bubbles formed after the nucleate boiling.
While studying and researching for this experiment, we encountered majorly three questions. The questions are firstly, how does the usage of two heaters affect the pool boiling and what happens if only one of them is used? So we anticipated that copper has some nucleation sites, and when the cartridge heater is inserted it helps in the formation of bubbles. And the second question was, how does the temperature of CHF occurrence, that is critical heat flux occurrence, depends on the test surface and surrounding fluid temperature conditions? And the lastly, why does the nucleate bubble formation observed only at a specific value of heat flux or the temperature? While studying, we found many graphs of the pool boiling heat flux versus TSAT, and majorly the maximum was obtained at 30 degrees Celsius. We hope to find this while performing this experiment.
So finally, me on behalf of our group, thank you for listening to us carefully. Thank you very much.